welcome to 13.4, Similar Triangles and Proportions. Okay, so the basic plan for proving theorems in this section is to use the division of each of the similar triangles into new triangles and to show that the corresponding triangles that result are also similar. So that's the goal here, and here's the first theorem. Similar triangles, the lengths of the altitudes extending to corresponding sides are in the same ratio as the lengths of the corresponding sides. So, as usual, we just need a picture to see what this means. So, if triangle ABC is similar to triangle DEF and AC is to DF equals 2, then CX is to FY equals 2. So, if CX is 3 units, then Fy is 3 divided by 2. That would be how we could find all the sides of both of these triangles. In similar triangles, the lengths of the medians extending to corresponding sides are in the same ratio as the lengths of the corresponding sides. So, do you remember that a median extends from a vertex to the midpoint of the opposite side? It's really important that we know all of our vocabulary from previous chapters. So given that ABC is similar to XYZ, we can find AD because we know they're similar. Otherwise, we wouldn't be able to. We don't have enough information. We don't have side angle side. We don't have even angle angle, and we definitely don't have even a right triangle. So we would be able to set this up. We would be able to say that AD is to WX as AC is to XZ. So then we could plug in some numbers. We know AC is 12, we know XZ is 8, and we know WX is 6. So we would be able to find AD by cross multiplying. And if you did all of that math and reduced your fraction, you would end up with 9. So if you're having trouble getting AD equals 9, go ahead and look in your textbook on page 557 and you can see all the plug-in, because sometimes just hearing it isn't helpful. You need to see it. I just didn't type in all those fractions because they're in your textbook. The next theorem says, in similar triangles, the lengths of the corresponding angle bisectors from the vertices to the points where they intersect the opposite side are the same ratio as the lengths of the corresponding sides of the triangles. The next one says, in similar triangles, the perimeters of the triangles are the same ratio as the lengths of the corresponding sides. We did things with this particular theorem in Algebra 1. We just never talked about it being a theorem before. So far we've seen altitudes, medians, angle bisectors, and perimeters are all proportional to the sides. So what do you think about the ratio of the areas? In similar triangles, the ratio of the areas of the triangle is equal to the square of the ratio of the lengths of the corresponding sides. This shouldn't be a surprise to you because the length of the sides are not squared, but area is units squared. So if I know the corresponding side ratio, I can square it and I will have the ratio I need for area. So here, if triangle ABC is similar to triangle DEF, the sides have lengths of AB is 12 and DE is 4. Those are corresponding sides. If I say 12 is to 4 and then I square that, you can simplify that fraction. It'll actually equal 9. So if the area of DEF is 6 square units, then the area of ABC ends up being 54 square units. Okay, so we're all the way down to practice problems. That's all for this particular section. So hopefully you'll find this fairly straightforward. Please remember to email your results and check your answers. I'll see you in class.